Hello and welcome to helpyourmath.com. In this video, we're going to look at more examples of factoring, and we're going to look at some more rare types of factoring. However, in all four examples, we will need to be familiar with the AC method or the target product target sum method. So make sure you know how to do that before you watch this video. If you need to review it, pause now, go back and watch a video that reviews the AC or the target product target sum method. Otherwise, we're going to get started. In our first example, we're going to factor out the greatest common factor. And we want to find that common factor such that the remaining factors have only integer coefficients. So the fact that they have integer coefficients only means that we need to factor out the fractions. We need to get the fractions out of this particular trinomial. How are we going to do that? Well, let's look at the denominators. We need to get rid of the denominators. Since the two denominators that I see are matching, right? This one doesn't actually have a denominator. We can write it as 1 over 1. That means that I want to factor out a 1/2. If I factor out a 1/2, that's going to take care of the two denominators of the 2. So how do we do that? Okay, well, what I'm going to do is I'm going to take the fractions and I'm going to rewrite them so that I can pull the 1/2 out ahead of time. So I'm going to break 5 halves up into 1/2 times 5, right? I can do that because I could put 5 over 1 and then we would be back at the 5 halves. So I have 1/2 times 5x squared. In the middle, I have 1 over 1. Well, I want a denominator, I want a half, but before I get to a half, let's get a denominator of 2. How would I get a denominator of 2? Well, I would multiply by 2 over 2. So I can think about 1 over 1x as 2 over 2x, and then I could pull out that 1/2, so I could say 1/2 times 2x, and then minus, I'm going to take 7 halves and rewrite it as 1/2 times 7, right? Because that would be like 7 over 1. Okay, so now I can see it a little bit more clearly. I want to factor out that 1/2. That would be 1/2 times, I'd be left here with 5x squared, minus, I factored out the half, so I'm left with 2x minus 7. Now we want to see if we can factor the trinomial. The trinomial has a target product of -35. So we're looking for target product, -35, and a target sum of -2. Are there two numbers that you can think of who multiply to -35 and who add up to -2? I can. -7 and +5. That would do it, right? They multiply to -35, they add up to -2. So we're going to expand the middle of the trinomial. That 1/2 just kind of chills out in front. And that would be 5x squared. I like putting my negatives first, so I'm going to write minus 7x plus 5x minus 7. Now that I have 4 terms inside the brackets, I can factor by grouping. So I'm going to group my first 2 terms, and I'm going to group my second 2 terms. Now what I'm going to do is with each grouping, I'm going to look for a GCF. So 5x squared and 7x have a GCF of x, leaving behind 5x minus 7. In the second grouping, 5x minus 7, they have a GCF of 1. And this is a very rare time where I actually write 1. Usually we don't, but just I like seeing that number because it helps me with the next step. So I'm going to factor out a 1, which actually doesn't do anything. And now we're ready to get these factored. So we're going to have our 1/2 out in front. The 2 terms that are inside the brackets have a common factor. They both have this 5x minus 7. So I can factor out a 5x minus 7 from both terms. And then what's left? X plus 1. So there I've successfully factored that very awkward looking fractional thing. I have the fraction out in front. And you'll notice that each other factor has integer coefficients and constants. So we're good. It's done. Yay! How about in our next example? So our next example, kind of the same situation. I encourage you pause the video, see how far you can get with this one. How'd you do? I knew you could do it. Let's review. So the common thing that we want to pull out here is going to be, or the common factor, I should say, not the common denominator. The common factor that we want to pull out here is going to be 1/8. So we're going to factor out a 1/8, or we can think about this. So I can take that 7/8 and rewrite it as 1/8. And how many 1/8 do I have? I have 7 of them times m to the 4th. In the middle, I have 6/8, or I can say that I have 6 1/8. So 1/8 times 6m squared. And then here I just have 1/8, and I can put a times 1 just so that I have a number there. We want to make sure that we continue to have a trinomial inside the parentheses. Don't lose that last term just because it happens to equal 1/8. Okay, so now I can factor out 1/8 and it looks really nice. I have 1/8, then I have 7m to the 4th minus 6m squared minus 1. Again, you should have a trinomial inside the parentheses. Don't lose that last term. Now let's see if we can factor this trinomial. The target product is -7. The target sum is -6. Can you think of two numbers that multiply to -7 and add up to -6? That's right, -7 and +1. So we're going to use that winning combination to expand the middle, keeping that 1/8 just chilling out in front, otherwise we ignore it. And we have 7m to the 4th minus 7m squared minus 1m squared, you don't have to put the 1 there, sorry, plus 1m squared minus 1. Okay, and now we're ready to, I have 4 terms inside the brackets, so I can factor by grouping. And I switched to brackets just because I knew I was going to be adding parentheses. It's fine if you have parentheses inside parentheses too. Okay, so now within each grouping, we're looking for a common factor. We have 7m to the 4th and 7m squared. It looks like we're going to factor out a 7m squared, leaving behind an m squared minus 1. Then over here, we're going to factor out a 1. That's going to leave behind m squared minus 1. Okay, so now inside the parentheses, I have 2 terms. This is one term, or inside the braces, excuse me, and this is a second term. Those 2 terms have a common factor, right? They have this common factor here. They both have m squared minus 1 as something being multiplied to something else. So we're going to factor out that common factor. That's m squared minus 1 times what's left, 7m squared from the first term and plus 1 from the second term. Now you might be saying, we did it, we're all done, hooray! And well, this isn't wrong, but it's not completely factored. Why isn't it completely factored? Because look right here, m squared minus 1, that's a difference of squares. Differences of squares factor into root minus root times root plus root. So we have one more step here. We have our 1/8 out in front. We're going to factor m squared minus 1, root minus root times root plus root. And then 7m squared plus 1, we can't factor that any further. So here we end up with 4 factors overall, and the only factor that has any sort of fraction is that leading coefficient, which is what we wanted according to the directions. Okay, how about this example? What are we going to do here? We want to factor out the greatest common factor. What is the greatest common factor here? So first, let's ask ourselves, how many terms do we see? I see 2 terms. One term is x plus 2 squared. The other term is minus 5 times x plus 2. Wait, I repeated myself, right? They both have a factor of x plus 2. So that's what I want to do. I want to factor out the factor of x plus 2. If I factor out x plus 2 from the first term, that's going to leave behind what? So that's going to leave behind a different x plus 2, because there were 2 of them, and then I factored 1 out, so there's still 1 that remains behind. And then what's left from the second term when I factor out an x plus 2? Well, the only thing left is this minus 5. So we would have something that looks like this. We might want to clean this up a little bit further, right? Because this is a little bit awkward. So this first one is fine, x plus 2. And then here we have x plus 2 minus 5. Well, plus 2 and minus 5 make minus 3. So we would have x minus 3. And that would be it. So it went from really awkward looking to, hey, that's kind of normal looking. Our last example, hit pause, try this one. Okay, what'd you find for your GCF? I figured out that there were 2 terms. Here's one term, and here's another term, and they both have a factor of 4x minus 1. So that's what I want to factor out. I'm going to factor out 4x minus 1, and from the first term that leaves behind an x minus 3, I'm just putting that second set of parentheses for emphasis. And what about the second term? What's left? That minus 2. So this is the first part. Can we make this look a little bit prettier? Yes, we can. First term is fine, or first factor is fine, 4x minus 1. Second factor is going to be x. We have minus 3 and minus 2. That would be x minus 5. And that would be our final factored version. These have been examples of factoring out the greatest common factor when things look a little bit more abnormal than usual. Thank you for stopping by.